In this lesson, we'll be talking about combining like terms. By the end of the lesson, you should be able to identify like terms and use the distributive property to simplify some algebraic expressions. Let's practice a little bit with some algebra tiles. So if we have this expression, and we use our algebra tiles to model this, we would have x minus 4, so we'll put 4 of these, minus x plus 2. So to simplify this, we're going to put our variables together, our like terms, and our constants together. And you know that if you have a negative and a positive together, you add them together, then they cancel out. So we'll throw those two away. We'll throw those two away. And we'll throw these two away. And that leaves us with negative 2. So that's the solution. That is the simplified expression for x minus 4 minus x plus 2. Let's try another one. Here we have 1 plus 2x minus 1 minus x. So if we combine the like terms, we'll put the variables together and the constants together. We have a negative and positive 1. And then we have a negative x and a positive x. So the simplified expression is just x. Let's try one more. So we have 3 plus x minus 1 minus 3x. If we combine like terms, put this over here and these together. So we have a negative x and a positive x, cancel each other out, 0 each other out. We have a 1 and a negative 1, and those 0 each other out. And we're left with negative 2x plus 2. And our last one, we have x squared minus 1 minus 2x squared plus x minus 3. So again, we're going to combine like terms. So our x squareds are going to go together, our x, and then our constants. So you can see that we have 1 positive x squared and 1 negative x squared. So our simplified expression is x squared, negative x squared plus x minus 4. All right, so remember that a variable is a letter that represents an amount that can be changed. So if we don't know what our variable is, we don't know how many lawns we've mowed yet, we don't know how many people that are going to the concert, then we're just going to put a variable in there because that amount can change. Our coefficient is the number in front of the variable. And whenever you have a number and a variable next to each other, that automatically means they multiply. And then our constant is the number that doesn't have a variable with it, and that number doesn't change. So like terms means same variable to the same power on the same side of an equal sign. Okay, those are like terms, and we're going to combine like terms. All constants are automatically like terms. So remember, an expression does not have an equal sign, so that means there's no solution. It's an expression. We're going to simplify it just by combining the like terms. An equation does have an equal sign, and then we need to solve for the variable. You're not done until you get down to x equals 5. So here we've got 3 expressions, and we're going to combine these like terms. So we have 3xy squared. So do I see another? Oh, here's another xy squared. Let's see. Oh, and here's an xy squared. So those all go together. Then we have an x, and here's another x, and here's another x. So those go together. And then we have x squared, x squared, y squared, x squared, y squared. Oh, don't see any more of those. So that'll be down by itself. Here's an x squared. So here, and this is an x squared. So I'll move this down this way. So we have all of our x squared, and then we have one x squared, y squared. Are 3x and 4x squared like terms? No. One has a squared, and one doesn't. Are 3 and 4 like terms? Yes. Those are both constants, so that makes them like terms.